Imagine this. You toss a coin into the air, and as it spins, you already know how it lands in every universe where it falls. In one, it's heads. In another, tails. And in countless others, it never lands at all. Suspended mid-spin between possibilities. That's the strange poetry of quantum computing. Machines that don't just calculate, but coexist in every outcome until reality decides.
To understand it, we have to step back into the world we already know, the classical one. Every computer you've ever touched speaks the same simple language, zeros and ones. Little switches turning on and off, again and again, billions of times a second. It's breathtakingly fast, but it still moves one step at a time, like a patient librarian flipping through a massive book, page by page, no matter how thick the story. Now imagine a machine that reads every page at once.
Welcome to the quantum world, a place where logic begins to shimmer and bend. Down here, the rules you know start to dissolve. An electron can be here and there at the same time. A particle can spin both clockwise and counterclockwise. The universe stops behaving like a clock and starts behaving like a dream. At the heart of it all lives the qubit, the quantum bit. While a normal bit can be either 0 or 1, a qubit can be both until it's observed. It's like that same coin, still spinning in midair. Not heads, not tails, but every possibility at once.
A classical computer is a creature of certainty. Every bit inside it is a decision, a light switch that's either on or off, never both. Billions of these tiny switches dance together, performing calculations at breathtaking speed. But no matter how fast it moves, it can only follow one path at a time. Imagine a maze. A classical computer sends a single explorer down each corridor, one after another, until it finds the exit. It's brilliant, yes, but limited by its own order. Now, picture a different kind of explorer, one made of mist. It flows through every path at once, touching all possibilities before choosing the right one. That's how a quantum computer thinks.
At the heart of this strange ability is something called superposition. It's the power for a quantum bit, a qubit, to exist in multiple states at once. Think again of that spinning coin. While it turns, it isn't heads or tails. It's both, suspended in a cloud of probability. Only when you catch it, when you look, does reality make its choice. That's what a measurement does. It collapses infinite maybes into one solid truth. And when many qubits exist together in superposition, something magical happens. They can explore countless versions of a problem simultaneously, weaving a map of all possibilities before settling on the path that works.
But superposition is only half the story. The other half, the truly haunting half, is called entanglement. Imagine two coins spun at the same time, one on your palm and the other light years away. No wires, no signals, no connection you can see. Yet, somehow, when one lands, the other instantly knows how to fall. That invisible link is entanglement, one of nature's strangest contracts. When two qubits become entangled, their fates intertwine. Change one and the other responds, even if they're galaxies apart. It's as if the universe itself keeps a hidden notebook, making sure every outcome stays balanced. In a quantum computer, this connection isn't a limitation, it's a chorus. Entangled qubits don't think separately. They think together. A ripple through one echoes through all, allowing the system to reason as a single, united mind.
So, what can a machine like that actually do? Think of the problems that overwhelm even our fastest supercomputers: simulating molecules,
predicting the weather, decoding the human brain. Each one demands tracking billions of interacting possibilities. A classical computer would drown in that ocean of data. But a quantum computer doesn't swim through it. It becomes the ocean. It can feel every current at once. That means it can design new medicines by simulating molecules directly, test new materials before we ever build them, optimize flight routes, or even create unbreakable encryption systems. Quantum computers don't just process information. They speak the same language as nature itself. And when that harmony works, it's not just faster, it's something deeper, like watching the universe think out loud. But this brilliance comes at a cost. Quantum computers are fragile, astonishingly so. A single vibration, a speck of heat, even a passing electromagnetic whisper can destroy the delicate state of their qubits. It's like trying to balance a soap bubble on the tip of a needle while composing a symphony. That's why they live inside chambers colder than outer space, vast metallic cocoons humming softly in the dark. Each one a sanctuary, protecting those fragile quantum thoughts from the chaos of the outside world. Even then, most quantum machines can only think for a heartbeat before reality catches up and collapses the dream. But within that heartbeat, they glimpse truths no ordinary computer could ever see. In a way, these two kinds of machines, classical and quantum, reflect two ways of seeing truth. A classical computer finds answers by eliminating what's false, step by step, until only one path remains. A quantum computer finds answers by embracing everything that could be true, and then letting reality decide which version it will keep. It's not just a faster way of thinking, it's a different philosophy. Classical logic demands certainty. Quantum logic thrives on possibility. And maybe that's what makes it so strangely human, because we, too, live in superposition, holding our doubts and dreams at the same time, never knowing which will collapse into the lives we finally live. Every decision we make is a kind of measurement.
Maybe that's the secret hidden inside all this strangeness. Quantum computing isn't just about machines, it's about us. We are made of the same rules, the same probabilities, the same shimmering uncertainty. Every choice, every possibility, every life we could live, they all exist for a moment together, until we choose one. So next time you hear words like qubit, superposition, or entanglement, don't think of cold machines in dark labs. Think of that spinning coin, glinting between heads and tails, caught in a quiet moment where everything is possible. Because somewhere between certainty and chaos, between logic and imagination, that's where the future of thought begins. That's where the quantum world lives.